Hello, my dear students. Today's class I will be discussing on strain energy, how the strain energy is stored in the body, what are the different types of the loading. Okay, so first I will say all of us we know that whenever some load is attached to a hanging wire, it extends and the load moves downwards by an amount equal to the extension of the wire. This you studied in the first unit itself. When the load is applied to the hanging wire, it extends and the load moves downwards by an amount equal to the extension of the wire. When the load moves downwards, it loses its potential energy. What is this potential energy? It is the energy possessed by a body by virtue of its position. This energy is absorbed or stored in the stretched wire, which may be released by removing the load. Okay, on removing the load, the wire will spring back to its original position. This energy, which is absorbed in a body when strained within its elastic limit, is known as strain energy. Okay, so here it has been experimentally found that this strain energy is always capable of doing some work. The amount of strain energy in a body is found out by the principle of work. Mathematically, we can say that the strain energy is equal to work done. Okay, so mainly this is the energy absorbed in the stretched wire, which may be released by removing the load, or you can define that when removing the load, the wire will spring back to its original position. This energy which is absorbed in the body when strained within the elastic limit is known as strain energy. So strain energy is nothing but is equal to the work done. So let us say some terms which is related to the strain energy. Resilience, it is a common term used for the total strain energy stored in the body. Sometimes the resilience is also defined as the capacity of a strained body for doing work. Means when it springs back on the removal of the straining force. Okay, so resilience is nothing but it is the capacity of a strained body for doing work on the removal of the straining force. Resilience, it is also a common term which is used for the maximum strain energy which can be stored in a body, and this happens when the body is stressed up to the elastic limit. Okay, the corresponding stress is known as proof stress. Okay, this is nothing but it is the maximum strain energy which can be stored in the body. Okay, so the corresponding stress is called as proof stress. This is about proof resilience. Next, we'll see what is modulus of resilience. The proof resilience per unit volume of a material is known as modulus of resilience and is an important property of the material. Then this is about resilience, proof resilience and modulus of resilience, and we'll see what are the different types of loading. Mainly there are three types of loading. The first one is a gradual loading, and second one is sudden loading, and third one is with impact. So we will see one by one. The first one is strain energy stored in a body when the load is gradually applied. So when the load is applied gradually, what is the strain energy stored in the body? That we will see here. This is the most common and practical way of loading a body. Okay, in which the loading starts from zero and increases gradually till the body is fully loaded. Okay, here it starts from the zero and increases gradually till the body is fully loaded. For example, when we lower a body with the help of a crane, you just imagine there is one crane, and when we lower the body with the help of the crane, the body first touches the platform on which it is to be placed. You just imagine, with the help of the, when the lower the body with the help of the crane, the body first touches the platform on which it is to be placed. On further releasing the chain, the platform goes on loading till it is fully loaded by the body. This is just one imagine. Okay, when the body is lowered by the crane, so what happens, first it touches the platform and then suddenly you have to release the chain, then only that uh, platform goes on loading till it is fully loaded by the body. So this is a good example for gradual loading. So now let us consider a metallic bar subjected to a gradual load. In such a cases, these are the terms you have to remember. Let P is a load gradually applied, A is cross-sectional area of the bar, and L is the length of the bar, and E is modulus of elasticity of the bar material, and delta is deformation of the bar due to the load. These terms you have to remember when you consider the bar subjected to gradual load. So there is a derivation is there. This is not so important. I just tell you how you get this final formula. Since the load applied is gradual and varies from 0 to P, therefore the average load is equal to P divided by 2. Here, because the load is gradually applied, so the value of P starts from 0 to P. So the average load is equal to here P divided by 2. We know work done is equal to force into distance. In this case, force is nothing but average load and distance is nothing but deformation. So load here in this case, that is P divided by 2, and deformation is delta L. So it is delta L. We know that deformation is equal to strain energy into L, because strain is equal to change in the length divided by original length. So the deformation is equal to, you can write E into L, strain into L. So simplify this, you get half into sigma square divided by E into A into L. Okay. Since the strain energy stored is also equal to the work done, therefore strain energy stored is given by this formula. U is equal to, this simplify this, sigma square divided by 2E into AL. So AL is nothing but area into length, that is equal to volume. So you can write U is equal to sigma square divided by 2E into V. So the modulus of resilience, that is nothing but equal to the strain energy per unit volume. So when you divided, this is the actual formula, sigma square divided by 2E into V. But this modulus of resilience is equal to per unit volume. So divided by V, this V we get cancelled, only you get sigma square divided by 2E. This is for modulus of resilience. So you just remember this formula. What is the strain energy stored in the body when the load is applied gradually? That is equal to, U is equal to sigma square divided by 2E into A into L, or sigma square divided by 2E into volume. Okay, this is the formula to find the strain energy when the load is applied gradually. Okay, let us take one example on this. Calculate the strain energy stored in a bar 2 meter long, 50 mm wide and 40 mm thick when it is subjected to a tensile load of 60 kilonewton. Take E as 200 GPa. Very simple problem this is. Direct substitution. What is given here? The length is given, that is 2 meter, convert into millimeter, 2 into 10 raised to 3 millimeter. And width of the bar, that is equal to 50 mm, and thickness of the bar is 40 mm. Now the tensile load P is given, that is 60 kilonewton, so 60 into 10 raised to 3 Newton, and modulus of elasticity, that is equal to 200 GPa, or 200 into 10 raised to 3 Newton per millimeter square. Now direct substitution here. In this case, we have that formula, strain energy stored in the bar is equal to, U is equal to sigma square divided by 2E into V. We don't know this sigma. sigma, so that we have to calculate here. What is sigma? Sigma is equal to load divided by area. So what is load? Load is equal to 60 into 10 raised to 3 divided by area. Area is breadth into depth, that is 50 into 40. So you get 30 Newton per millimeter square, that is stress. Once if you get the stress, you can calculate what is strain energy stored in the bar, that is equal to this formula, sigma square divided by 2E into volume. So sigma is 30, so 30 square divided by 2 into E is 200 into 10 raised to 3 into volume is area into length, that is nothing but 50 into 40 into 2 meter, 2 into 10 raised to 3. You get this 4 into 10 raised to 6. Why? Because 5 into 4 into 2, correct? So that is equal to 4 into 10 raised to 6 Newton millimeter. Because this is Newton millimeter is strain energy unit. Simplify this, you get 9 into 10 raised to 3 Newton millimeter or 9 kilonewton millimeter. So in this way you can calculate what is the strain energy stored in the bar. Very simple example, direct substitution. You should know there are three types of loading: gradual loading, sudden loading and impact loading. So for these three loading, the strain energy formula is different, or stress may be different. So for the different cases. So we'll see the next case in the next lecture, means the sudden loading, what is the formula for stress and what is the formula for strain energy. Okay, thank you.